Auzubillahi Bismillahirrahmanirrahim. Let's start the sixth lecture. And if you remember, what we are doing at that time, we are started with the multiple integrals and did three examples of that. We are doing with the three kinds of multiple integrals with x and y as variable, in which I told you that there are three styles of double integral. In the first, you may have the integration that you have to integrate with respect to x first and then with respect to second. Vice versa, in the second, you have the initial idea in the question that you have to integrate y first and then with respect to x. And in general, we have questions like we did in the third example, that we need to decide that whether we have to do integration with respect to x first or with respect to y first. Generally, we can do in both ways if we have the limits of both x and y. So I am continuing with the same examples to establish the idea that we can do either with respect to x or with respect to y first, depending on the limits given in the question. So starting with example number 4, and in this example we have to evaluate the integral over the region R, and the term is xy, and we have to integrate with respect to x and y both, where R is the quadrant of the circle Let's say circle is x square plus y square equal to a square, and x is greater or equal to 0 and y is also greater or equal to 0. So generally, we need to first make a figure in which we can assess that which portion needed to be integrated. So that's why, let's say this is x-axis and this is y-axis, and we need to make these three lines. So x is greater or equal to 0. So x equal to 0 is this line. This is x equal to 0 line. This is y equal to 0 line. And finally, we have this circle. So let's say this is the circle x square plus y square equal to a square. So now the question arises, why I didn't plotted the whole circle. Actually, this is the whole circle. Let's say this is the whole circle, and I am only considering its positive quadrant. Why? The reason is simple and obvious, because the line x is greater or equal to 0 and y is greater or equal to 0, showing that both these values are positive. So this is the positive quadrant for both x and y. So we need to take the area which is covered by all this curve and these two lines. So this is the first quadrant in which we need to find the integration part. So now it is easy for us that we can find that this is the origin. Let's say this point is A0. Why it is A0? Because the radius is A, R is equal to A, and this point is 0A. So we find out the points, exactly the points where the circle is lying. Now the proper solution, in first we integrate with respect to y. So it means y is equal to under root a square minus x square. First we integrate with respect to y, having limits, and then with respect to x. So first we integrate with respect to y and then with respect to x. The limits of y will be, so now we have to analyze that what will be the limits of y. So limits of y will be 0 and this one 0 and under root a square minus x square, and the limits of x will be 0 and a. So if you go vice versa, which I suggest you to do yourself, then in that you have to integrate with respect to x first and then with respect to y. And I will tell you the limits as well when we finished with this one. So now we are integrating this integral. This is r x y dx dy will be equal to. So since we are differentiating with respect to y first, so the limits of x will be 0 to a and the limits of y will be 0 to under root a square minus x square. And you know that x will be treated as constant, so 0 to a. So this will be x into y square by 2 and the limits will be 0 and under root a square minus x square dx. The integral of y will be y square by 2. So now if I substituted the values, this is 0 to a, so this is x by 2. On substituting the upper limit, this will be a square minus x square because the root cancels with square, and then 0 square, and this is dx. So it means we can easily write that 0 to a 1 by 2 a square x minus x cube dx. So now we will integrate this term, and if we integrate this is half, and then we have a square x square by 2 minus x4 by 4, and limits are 0 to a. Limits are 0 to a. So now on substituting the limits, so this is half, this is a square into a square by 2, this is upper limit, minus a4 by 4, this is lower limit, and then minus a square into 0 square by 2 and plus 0 power 4 by 4. So upper limit minus lower limit. So it means we only have half a power 4 by 2 minus a power 4 by 4. So it means a power 4 by 4. It means a power 4 by 8. So this is the answer of this integral. So now my suggestion is to do yourself the same question, and what change you need to do is to integrate with respect to x first and then with respect to y. You need to integrate with respect to x first and then with respect to y. So what change will occur? Then you have the limits of x will be as 0 and a square minus y square. Instead of x square, I will get the value of x from here. So it will be a square minus y square. And then the limits of y will be 0 to a. And you will see that you have the identical answer. So you need to do the same example by switching the order of integration. So let's move on to another example. So now the term we are going to find example number 5. In this example, we need to evaluate almost the identical integral, but what is the difference is the area where A is the domain bounded by x-axis ordinate x equal to 2a, ordinate x equal to 2a, and the curve y square is equal to 4ax. X square is equal to 4ay. X square is equal to 4ay. We have the same integral, but we have the different region to be integrated. So like the previous example, again what is the need is to draw the figure to know that which area is need to be integrated. So x-axis, this is x-axis, so it means that on x-axis we have y equal to 0, the line, so x-axis means y equal to 0, then we have the line x equal to 2a, so where a is any arbitrary value. So let's say that this is a and this is 2a, so I have the line, this is the line x equal to 2a, so this point become 2a0. And then we have the curve x square is equal to 4ay. So it means I can, if I draw this, almost it will be like this one. So this is y equal to x square upon 4a, or x square is equal to 4ay. So now we have all these three values. So if you try to find that what is this point, we know that this is x equal to 2a. So this is 2a, and what will be the value of y if I substitute the value of x equal to 2a here, because this is the intersection of this and this line. So if I substitute x equal to 2a here, the numerator will be 4a square, so y will be equal to a. So simple idea is that how we can find this point. This point is the point of intersection of x equal to 2a and x square equal to 4a y. So now we have this region to be integrated. We need to integrate this region. So if I say that this is O, A and B, if I name these, then this will be simply equal to O, A and B. So solution is the area of integration is OAB as seen in figure. So this is the area which need to be integrated. Here again, here we integrate with respect to y first and then with respect to x. I am following the same idea. So the limits of y are 0 and x square upon 4a, and the limits of x are, the limits of x will be 0 to 2a, 0 to 2a. Therefore, when we integrate this entire region, we will write as 0 to 2a, then we have 0 to x square upon 4a xy dy and dx. So now again, as we did in the previous example, this is 0 to 2a. So now we have x into y square by 2, and limits are 0 to x square upon 4a dx. So it means when we substitute these limits 0 to 2a x upon 2, substituting the upper limit, this, so it becomes x power 4 upon 16a square minus 0, and this is dx. So it means now we have the simple term as 0 to 2a, 16 2s are 32, so we have 1 upon 32a square, and x into s is x power 5 dx. So we simply need to integrate x power 5. So it means 1 upon 32a square, and we integrated it, means x power 6 by 6. So this is 0 to 2a. So it means this is equal to 1 upon 6 2s are 12 and 192a square, 32 6 are 192, and then we have 2 power 6 a power 6, 2 2 5 32 64, 2 to the 4 4 to the 8, 8 to the 16 32 64. Yes, 64 a power 6. 64 a power 6. So it means what we have is only a power 4 upon 3. So this is a power 4 upon 3. This is the answer of this portion. So now again, just like previous example, you need to do the same example, but now you need to integrate with respect to x first and then with respect to y. So I am telling you what will be the limits of x and y. So if we integrate with respect to x first, the limits of x will be, this is 2a, and then this is the value of x will be equal to under root 4a over y. So the limits of x will be, if we integrate with respect to x first, the limits of x will be 2a to under root 4a over y, and then limits of y will be 0 to a. Limits of y will be 0 to a. So again I am telling you, when you did do the same question, but with respect to x first, the limits of x will be 2a to under root 4a over y, and then with respect to y, limits will be 0 to a. So now this concludes this example, and now we are moving on to another example. So solving at least one more example before finishing this first part of lecture number 6. So now we are going to solve another example. So this is example number 6, and now we need to evaluate the double integral over the region S, and this is xy minus y square dx dy. And what is S? Where S is a triangle, having vertices, what are the vertices? 0, 0, 0, 0, 10, 1 and 1, 1. So these are the vertices of this triangle. So again, first drawing the vertices. So this is 0, 0, this is 0, 0. Then we have 10, 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let this is say 10, and this is 1. So it means I had this is 10, 1. This is no. So this is, let's say, point 10 and 1, and this is the point 1, 1. So this is the triangle in which we need to find the area of this triangle. Let's say this is O, this is A, and this is B. So this is B and this is A. because the order was this and this, so O, A and B. So the solution is the area of the triangle OAB is the area of integration. So what we said, the area of the triangle is the area of integration. So now it is important that we find out that what are the equations. So if we go along this line, this will give you x equal to y. This line will be. Now it is very easy to find the equations of these lines, because if we have 2 points of any line, then by using 2-point form we can easily find the equation of the line. So if we use 2-point form between O and B, then you can easily find the equation of the line. Then if I found the equation of the line of this is OA, this will be equal to x equal to tan y. So this will be equal to x equal to tan y. This will be the equation of this line. So again, now integrating with respect to y first and then with respect to x. So again, doing the same pattern or following the same pattern, we need to integrate with respect to y and x. So, but if I switch, I give 2 examples with respect to y first. So let us try with respect to x first. Let's say I am trying in vice versa way, as I am telling you, you have to do in example 4 and 5. So now I am switching, I am doing with respect to x first and then with respect to y, and then you will follow the same idea. So the limits of integration with respect to x are, so the limits of x will be y to tan y, and the limits of x will be 0 to 1. So the limits of x will be 0 to 1 and the limits of y will be the limits of y will be 0 to 1 and the limit of x will be y to tan y. So now I am integrating under root xy minus y square dx dy is equal to integral 0 to 1, then integrating y to tan y, and then xy minus y square power 1 by 2 dx and dy. So it means treating y as constant, so it means 0 to 1, then it will be x square by 2y minus xy square, and limits are y to tan y, and now we have dy left. So then substituting the limits, we will get 0 to 1. So if I substitute in place of x, this is tan y means 100y square upon 2, it means 50y cube, 50y cube, and then minus here tan y cube. This is upper limit, then minus lower limit then y cube by 2, y cube by 2 and minus plus y cube, and this is dy. So it means 50 minus 10, 40, 50 minus 10, 40 minus 1 by 2 plus 1, so 2, so it means 80 minus 1 plus 2, it means 81 by 2. So it means we have 81 by 2. No. I made a mistake. I did not counted this whole power. So this is the mistake. So integration is wrong. So I am correcting this integration here. So because the whole power was half, so what is required? We need to find the derivative of this thing, and since y is treating as constant, so what will be the derivative will be xy minus y square 1 by 2 plus 1 3 by 2, and the derivative of xy minus y square is y, and this is dy. Y and 3 by 2 is 3 by 2y. So this is the way to integrate this one. So it means now we need to substitute the values. Values will be y and 10y. So it means now I have 0 to 1, 2 by 3y, and then I have 10y, means 10y square minus y square, 9y square, and then y square minus y square 0, so 9y square whole power 3 by 2 dy. So when we simplify this thing, we will only get 18, 0 to 1 and y square, simple y square and dy. So it means now we have 18 y cube by 3 and 0 to 1. So limits are simply 0 to 1. So it means 3 6 are 18, 6, 1 cube minus 0 cube. So final answer is 6. So now you need to solve the same example, but then you need to integrate with respect to y first and then with respect to x. And now I am leaving on you that what will be the limits of y if you integrate with respect to y first, and what are the limits of x when you integrate with respect to x second. So this concludes the first part of lecture 6A. Inshallah we will continue with this in the second part. So that's goodbye now.